Running on Ice, the coolest community in freight. I'm your host, Sydney Edwards, bringing you the latest tech updates, warehouse news, everything happening in the cold chain world. Now, you know Running on Ice, the show. You know Running on Ice, the newsletter, the one that I write every Wednesday and Friday, covering the same topics. And you can check that out at freightwaves.com. Subscribe to that newsletter, and you'll get all of those updates. Now, today I'm joined by two very special guests. I've had them on the show once before, so you might recognize them. It's Dr. Bob DiLoreto and Dr. Cliff Glade with Thermal Custom Packaging. How are the two of you today?
Doing great, Sydney.
Everything's good, Sydney.
Great. So today I would like to get a little bit into some of your background just to begin with. I know we've had you on the show before, but for some people who maybe didn't catch the show or haven't been listening, we'll just go ahead and start. And we'll start with you, Bob, if you could just give us a little bit on your background and you starting with Thermal Custom Packaging.
Sure. I'm a urologist, retired urologist that practiced about 40 years. In the course of those 40 years, I got involved actually about 30 years ago with the FDA, which I still am on, looking at devices for urology and gastroenterology, and have sat on numerous panels, immunology panels, drug panels, et cetera. I'm actually located in Michigan, but years ago purchased a home business down in the Florida Keys, right near Dr. Glade, Cliff Glade, and we became friends. And pre-COVID, actually started taking my dogs to him. Pre-COVID, we've had some conversations about what he was doing independent from his job. And his other job, I should say, and started working with him and Thermal Custom Packaging related to more the medicine side of the industry as opposed to just the normal cold chain side of the industry.
Bob, thank you so much. And Dr. Cliff Glade, I know Bob just mentioned a little bit of the work that you do, considering the veterinarian work that you do. Give me a little bit more on your background and how things began for you with Thermal Custom Packaging.
Yeah, so Bob is correct. I've been practicing veterinary medicine for 43 years. Prior to that, I was a medical doctor. And about 20 years ago, I started working with transporting medical specimens for one of the largest nonprofit, or actually the largest nonprofit healthcare in the United States. And we found Thermal Custom Packaging, and we started making their insulated containers and their chemical reactions that maintain them refrigerated, frozen, and ultra cold, because they wanted to replace all dry ice. And we still have them as a client. They're an excellent client. We move pretty close to, with our equipment, 250,000 specimens every morning. And those specimens would be blood samples, whole blood, tissues, allografts, organs, pathology samples, biological pharmaceuticals. We expanded out into moving evidence, temperature-sensitive evidence, and more recently in frozen foods.
Perfect. And today we're going to be talking about the future of vaccines. And as you just mentioned, Thermal Custom Packaging's background involves working on the packaging and some of the movement for what really started, as you just mentioned, in medical products. But, you know, you've made the jump into a lot of different parts of the industry. And of course, with you two as physicians, it wasn't really that large of a jump for you to get involved in something like this. And so we're going to be talking about the state of vaccines and what things could be turning into. I'd like to ask, and maybe I could start with you, Cliff, while I've got you. What are we seeing right now as a shift for vaccines?
Well, the latest and greatest thing that we're starting to look at is intranasal vaccines. And there are a lot of advantages, and of course there are always some disadvantages. Intranasal vaccines versus an intramuscular vaccine produce a different type of immunity. And Bob, step in at any time if you have something to add. When you give an intramuscular injection, you get what we in medicine call an IgG type reaction, which means that when you're exposed to the disease, the body has learned how to make antibodies against the disease. But first, the disease has to enter the body. With certain types of diseases, for example, kennel cough in dogs, you don't want the dog to get the disease. You want to block it prior to him getting sick. So we use a intranasal or a oral in his mouth vaccine, and you create what we call IgA immunity, which is a mucosal. Think about the respiratory tract, the GI tract, skin. Those are various coverings, and these IgA attack the viruses at where the viruses try to enter the body. So, the intranasal vaccine is one route of vaccination for creating IgA reaction, and there's a lot of advantages. It can be administered by a simple device. You no longer need a syringe. It can be a plastic bulb to spray it up in the nose. It doesn't require a sterilized setting like a intramuscular vaccine does. That's particularly beneficial in developing nations. You can also easier to use non-professionals. We don't always need a doctor or a nurse to spray something in the mouth or the nose. Very often, intranasal vaccines allow for a lower dosage of the virus, the attenuated virus, than a muscular injection. And perhaps very important is they stop they can stop the shedding of viruses at the level of the mucosa of the respiratory tract, which, what does that mean to the population? It means that your exposure is not as high. So the person who's sick is not able to keep putting out those viruses in the air. So those are some of the advantages. Bob, do you have anything to add that you'd like to add?
Sure. I actually sent you some stuff, Sydney. You probably didn't want to look at it all, but the 10,000-foot view is obviously the current vaccines, and these just aren't the COVID vaccines. This is numerous other vaccines, but in particular that everybody's aware is the COVID stuff. There's all kinds of research going on right now about new vaccine types and new vaccine delivery systems. And a lot of this was because of the issues and the problems with the COVID vaccines, in particular, the original ones were at dry ice transport and storage, and then a higher temperature for distribution. But they would only last so long because those temperatures were fairly cold. Now, we happen to have some products at minus 21 degrees C that allowed us to transport the vaccines into or through what we refer to as the last mile, beyond the delivery to, as an example, the state of Florida that would deliver them to the hospitals or to CVS or whomever, and then being able to store them at a less cold temperature for delivery, or in rural areas, go from, say, a hospital out through the visiting nurses, to 30, 40 or more miles away. We were able to manage that, but it created a lot of issues related to transportation and delivery, and particularly the rural areas. These nasal vaccines, which actually have already been approved in China and India, considered the population and the delivery into that extremely rural population, have been approved and they're being used there right now. The vaccines come in an aerosol or a gel or a powder, But for the most part, the storage of these is in the 2 to 8 degrees centigrade as opposed to the minus stuff. And we actually have products for delivery and storage and transportation for those. But the main point is there's lots of needle phobia. People don't like getting injections. There's issues of getting the product out, and I would bet that given a couple of years, that the bulk of these vaccines are going to be delivered nasally or intranasally because of actually what Cliff said. Vaccines stimulated an immune response, and that immune response is supposedly going to protect you from getting the virus and getting the infection. But that's not the same thing as actually having a barrier in the lung system and the nasal system that actually prevents the viruses from getting any further in than just those areas. So it can significantly reduce the chances of infections, and as Cliff said, can reduce the chance of shedding of the virus to give it to other people. So I would suspect there's going to be a major shift in a few years when these are approved all over the world, that this is probably going to be the primary source of vaccine delivery, particularly for the respiratory viruses, which COVID and flu and those type of things happen to be the majority of the reasons, at least at present, that we're looking at delivery systems and new vaccines.
Bob, thank you so much. And I did read what you sent me. I went through every page. I did. And so I'm following what the two of you both are coming up. And I wanted to dive a little bit more into something that Cliff had mentioned environmentally, how a nasal vaccine might be more beneficial. You mentioned even needle phobia and the above. So maybe, Cliff, could we talk on an environmental standpoint, how this differs from current vaccines and what's being used, and maybe how cold storage differs in that way too? And is that something that is more environmentally friendly when they don't have to be kept at such cold temperatures?
Absolutely. Think about third world countries where a large part of our world population lives, and how hard it is to do freezing, how much easier it is to do refrigerated. Think about some village in the middle of nowhere and getting a trained healthcare professional versus teaching a village elder how to do a nasal vaccine, because you're not injecting. There's no sterilization of a needle. You're blowing what we call an attenuated virus. It's a virus that's been made to theoretically not activate and get you sick, up into the nose. So you could train someone to do that much simpler. And babies hate to be injected, but my own daughter is a challenge to inject, and she's not a baby. She's 34 years old. I always have to tell her on the count of 3 and then hit her on 1. It's just so much easier doing an intranasal vaccine.
And from one
Sydney,
of the articles, go ahead.
I'm sorry. The other point, and you started the challenge of the vaccine types and potential issues beyond the virus and beyond the person getting it. Eliminating the need for dry ice for transport is a huge issue, and particularly with the current climate. That's the wrong word, but the green climate change things that are going on right now, and these gases that come out of in particular the dry ice. That's completely eliminated. And as well as the cost of making the dry ice and how fast it dissipates or evaporates. There's a huge dollar saving. There's a huge client or climate savings and improvement by not using dry ice. And so this is beyond just the delivery of the system and the better immunity to the person and the prevention of shedding of further virus particles because of the mucosal barrier. It's an enormously important issue.
We've talked about the advantages to a nasal vaccine. What about anything that is a disadvantage? What is a challenge of a nasal vaccine? Are there any side effects that tag along with using a nasal vaccine, or anything that, for any reason, why we shouldn't be using nasal vaccines that much?
Now, potentially, there are certain dangers. The olfactory nerve runs from the nose right to the brain. So potentially, you could bypass the blood-brain barrier and give yourself a central nervous system infection. This is all handled at the level of testing and the FDA, and we have to be cognizant. We have to not rush into things and later on have issues. Another issue with using a nasal vaccine is it's wonderful at stimulating IgA, or surface level immunity, at the upper and middle level of the respiratory tract, but not so good at the lower level of the respiratory tract. And that can create issues where it's not as effective. The other issues is the pathogen is weakened. But there have been many cases, and Bob can join in on this, where flu vaccines have caused Bell's palsy and various other issues. And this is, you protect the population by testing properly prior to just putting it out. We have to make sure that we don't allow the political climate to quickly push vaccines out before the FDA and the CDC have had a chance to properly examine what can go right and what can go wrong. But you're absolutely decreasing the chances of something going wrong when you make it easier from a temperature viewpoint to just refrigerate it, or with a dry vaccine to be ambient, versus the complex process of making a vaccine that has to be minus 21 or minus 19 and then prior to use beyond thawed and kept refrigerated. The more complex you make a process, the more likely there'll be issues. We were involved with the second largest school system in the United States that came to us and requested help vaccinating, oh, Bob, I don't remember how many thousands of people in a couple of weeks.
It was like 40,000.
Some ridiculously high number, and it was their personnel. So we had to move vaccine at minus 21, get it to outside vaccination clinics, refrigerate it, all without refrigeration. We did it. It was very successful. But this took place in the United States. It would have been a real challenge in a third world country to get this done. So the more simple we make the process, and the easy, moving away from the dry ices, the more likely we'll get this done. The one thing Bob didn't mention is our products are sustainable. They're green, reusable. So besides from the fact that they don't let off CO2 and affect climate change, they also are extremely green. And every one of our large clients, specifically the new food industries that have been coming to us, harp on this. They're trying to get away from dry ice. They're trying to go green. And we finally gave them a solution.
I was going to ask, since you brought up, we've been talking about underdeveloped countries and how tough it is to get vaccines out there, and cold storage and all the above. And I think that I've expressed my passion towards underdeveloped countries in getting them the cold storage, and just how I feel about that issue. There are many countries, there are many companies that are working on, I'm going to call them warm vaccines, that don't have to be put in cold storage, that don't have to be kept at such low temperatures. Do you think a nasal vaccine instead of just a warmer vaccine might be a better option than that?
From that list, that one picture you had put up a few minutes ago,
Mhm.
the powdered and this doesn't really address the how they're produced and store and manufactured. The powdered type nasal vaccines are just ambient room temperature. That's literally it's way up at the top there in the red, and so those are no issue at all. The other ones are 2 to 8 degrees C, which basically is refrigerator and freezer freezer temperatures at the most. Common refrigerators and freezers, nothing medical scientific type stuff. So the trend is to either allow ambient delivery and storage, or just standard refrigeration / freezer type storage, which makes it much more accessible to a rural audience. So there is a shift in that direction with the new, at least nasal type vaccines.
Absolutely. It's just such an interesting concept. I'm curious if you believe that there are other vaccines that could move into a nasal concept. COVID-19, I'm assuming, of course, as you mentioned, that they're already working on that in China, I believe Iran, Russia, and India, as you mentioned. What other vaccines could be made into a nasal vaccine? Or are there certain, is the chemical makeup of some of these vaccines, there's no way that it could be made into a nasal?
It's more
I think
what type of are you trying to receive? So respiratory diseases lend themselves to intranasal. Go ahead, Bob.
One interesting point is any vaccine that you inject obviously has to circulate to your immune system, your internal immune system, and interestingly enough, the bulk of its lymphoid tissue, the bulk of the lymphoid tissue is actually in the head and neck area. And so rather than having something injected in your thigh or your arm or something and this is for not just the respiratory vaccines, but vaccines in general, trying to create an immune response, something that is going to hit the primary immune producing areas. Think of tonsils. Tonsils are lymphoid tissue, and a bunch of the other areas in the head and neck are extremely dense lymphoid tissues. And having them be able to get there directly is a huge advantage as opposed to the IM injections and then circulating. So, and it's to be determined, but it may be a better vehicle for administration for lots of different diseases. That's just to be determined, and that's again what the studies are going to show. Just to address, at least from a personal standpoint. I was not real happy at and I understand the need for the COVID vaccines to get out, but the emergency authorization that occurred to get the bulk of the stuff out in the beginning to adults, I think was a smart idea. But all of the boosters and then the going forward, the pediatric doses were all based on animal studies, and towards the end, some of these boosters were not even done using mice to test on them. They were just approved based on the fact that they were approved elsewhere. And I have personally an issue being on the FDA for such a long time for these things coming out and being used on kids, as opposed to a 50, 60, 70-year-old person whose life expectancy is, much different than a newborn. So I think the important point is anything coming forward needs to be thoroughly evaluated and tested by the standard procedures that have always been present. And having done that, we should reduce any negative, negative long-term effects that people are questioning right now with the current COVID vaccines.
Bob and Cliff, thank you so much for joining the show. It's always a joy to have you on. I will be putting your emails up on my newsletter and on thefreightwaves.com, where people can subscribe so that they can learn more from you and for Thermal Custom Packaging. So I just want to thank you again for joining the show, and it's been great. We will be checking in with you another time. I know it.
Thank you, Sydney.
Thank you, Sydney.
Now, as I mentioned earlier in the show, Running on Ice, the newsletter, comes out 7 p.m. Friday night, tonight. We'll have more information with you there, including this interview that will be linked so you can watch the whole thing if you've missed it. And next week, I have an open slate. So if you know somebody in the cold chain world that would like to be on the show that you think would be great, find me on LinkedIn, Sydney Edwards, and shoot me a message, or you can shoot me an email. It's sedwards@freightwaves.com, and let me know who can be on the show. Stay tuned.